So let us solve another problem on CPM and PERT. The problem looks like this. For the network shown, determine the probability of completing or determine the CP critical path, right? Then critical path and the probability of completing the project in number 1 35 days, comma number 2 30 days. So this is the network given. So there are totally 5 events. Event 1 is connected to event 2 with the values of times 6, 9, 18. Please note that the first value represents T0, second value represents TL, optimistic time, likelihood time, and pessimistic time. Third value TP. It is in the increasing order. Then 1, 3 activity with time estimates 5, 8, 17. Then 3, 4 time estimates being 4, 7, 16. Then 2, 4 time estimates being 4, 7, 22. 4, 5 time estimates being 4, 10, 22. Then you have 3, 5 time estimates 2, 5, 6, 2, 5, 8. Then lastly you have 2, 5 time estimates 4, 7, 10. Yes. This is the network for a project given. We have to first determine the critical path, then probability also. So this is your PERT, probability finding, project evaluation and review technique. Now as I told, these 3 values are the time estimates. So now we can, once time estimate values are given, T0, TL and TP, we can find out the expected time TE using the formula T0 plus 4TL plus TP divided by 6 weighted average. So this is the first formula we have to use, because TE is not given. We have to find out TE for all these networks now. Now let me write the diagram once again, because I want the TE values. So 1, 1 to 3, then 1 to 2, then you have 3 to 4, then 2 to 4, 4 to 5, 3 to 5, then 2 to 5. Now let us calculate the TE values for all these. So I will write TE value below the activity. TE for this, TE for this, TE for this, TE for this, TE for this. All the TE values are in days. Okay, so all, I will write here, all time estimates are in days. Okay, now let us use this formula first to find the expected time of each activity using this formula. Now for the first event, so for the first activity 1, 2, you just calculate that. So for the activity 1, 2, if you use this formula, it is 6 plus 4 times 9 plus 18 divided by 6. So estimation of PE. To find PE.
9.67.
So the first value is 6 plus, okay, I will write here for 1 2. 6 plus 4 times 9 plus 18 divided by 6. What is the value?
6.
Huh?
10.
10. 6 40, okay, 10. Then for 1 3. 1 3 it is 5 plus 4 times 8 plus 17 divided by 6. 9. Then for 2 4. For 2 4 it is 4 plus 4 into 7 plus 22 divided by 6.
9.
It is
9 also.
9. Then for 3 4 activity it is 4 plus 4 times 7 plus 16 divided by 6.
8.
8. Then for 4 5. For 4 5, 4 plus 4 times 10 plus 22 divided by 6.
11.
Then for 2 5, 4 plus 4 times 7 plus 10 divided by 6.
7.
The last stage is 3 5. So for 3 5, it is 2 plus 4 into 5 plus 8 divided by 6. It is 5 8. Correct? Now we will write all these values there. For 1 2, the value is 10. T is 10. 10 days. Then for 1 3, it is 9. For 2 4, it is 9. Then for 3 4, it is 8. For 4 5, it is 11. Then for 2 5, it is 7. Then for 3 5, it is 5. So this is the first step. If these values are given directly, you need not use this. First step is over. Next, second, after getting TE, to get the critical path, we need to compute other two time estimates. One is capital TE, another is capital TL. So to find capital TE. So last video I had explained all this. On similar lines we are doing this. So this is the earliest expected time. This is expected time. This is earliest expected time. Earliest expected time is given by, suppose if ij is the event, if ij is the activity, you can say, if ij is the activity, then tej will be equal to tei plus small teij. So this is the formula we are going to use. So first formula is this, second formula is this. Okay, this is to calculate capital T. Now we go in same order. So 1 2. So 1 2 means I want now T values are written above the circle. Above the circle I am going to write all the T values for each event. Circles represent the events. So capital T values I am going to write above the circle. Small t are written below the line activity. So T. So we need 5 values now. Once again, if there are 2 arrows are meeting, you have to take the maximum value here. So first I will take up T1. So let us assume T1 has 0. Initially, normally it is taken as 0. That is the starting point. Now TE2, I want TE2. TE2, if I take this path, TE2 will be TE1 plus small TE12. So TE1 is 0, small TE12 is 10. So therefore it is 0 plus 10, it is 10. So this value is only one arrow going from this, going from 1 to 2. So now therefore this is the only one value. So TE2 will be how much? 10. This is over. Next, TE3. For TE3, I have to take this activity. Only one activity is leading to 3. So TE1 plus TE13. So TE1 is once again 0. TE13 is 9. So therefore it is 9. So only one. So it is 9. That's it. Next, we will go to 4. If you are going to 4, you should be careful. There are two activities are connecting to 4. So TE4 you can find out using two activities. One is TE2 plus small TE24. TE2 we got 10. Small TE24 is 9. So 10 plus 9, 19. TE4 can be found out using another path, that is from 3. So TE4 is TE3 plus small TE34. TE3 is 9 plus small TE34 is 8. So 17. Now among these two, which one you have to take? You have to take the maximum value, greater than. So this is maximum. Therefore, your TE for 4 is 19. Yes. Next, coming to 5. There are 3 arrows leading to 5. So we have to find out 3 values. Among that, we have to take the maximum. So TE5, I will write. If I take this from second, TE2 plus small TE25. TE2 is 10 plus 7, 17. Next, TE5 can also be found out using this, coming from 4 also. So TE4 plus small TE45. So TE4 is 19 plus 4 5 is 11, so 30. Next, TE5 can also be found out using the last one, that is TE3 plus small TE35. TE3 is 9 plus 5, 14. So among these three, the maximum value is 30. So therefore, that is your capital T for event 5. So that is 30. So this itself is your scheduled time. Okay, the expected time, earliest expected time of the last event itself is the scheduled time, TS. So 30 we got now. So this is how we can compute T. Next step is to find what? TL. To find TL, latest available time. Okay, just like TE, you have to find out TL. For this, the formula is, I have given in the last videos also. Here TL of I we are going to get by knowing TL of j minus TE of j. So here minus will come, and here we have to take the minimum value. So that is the formula. So 3 formulas, 1, 2, 3. Now here, one by one we will go now. We have to start backwards. I told you, for calculating TE, we have to move from the first event. For calculating TL, you have to move back from the last event. So last event now here is TL5 we know, which is nothing but your TS, which is 30 days. That you know. Now I have to move backwards. TL4 I need. If I want TL4, it is 4 is connected to 5 only. So TL5 minus TE of 4 5. So which is 30 minus TE of 4 5 is 11. So which is 19. This is one value. So only one value is correct because only one arrow is preceding this. Next, so this is 19. So I will write all these values below the line. So that means TL I will write. Here this TL is also 30. Now TL of 4 we got as 19. 19. We have to write below the circle. Next we will come to 3. So be careful here. TL of 3. So if you want a TL of 3, we have to take 4 also, 5 also, because they are connected to 3. So TL of 3 we have to find out using this both. So if I use 4, TL of 4 minus TE of 3 4. TL of 4 is how much? 19. Minus TE 3 4 is 8. 19 minus 8 is 7, that is 11. Next, TL of 3 can also be found out. There are two options here. By taking this 5, because this 5 is also linked with 3. So it is TL5 minus TE of 3 5. TL5 is 30 minus TE of 3 5 is 5. So it is 25. So among these two we have to take the minimum we have to take. So among these two, minimum is this 11. So when you are finding TL, you have to take the minimum. When you are taking TE, you have to take the maximum. So TL3 is now 11. So we have to write here. TL is 11. Next is 2. We have to come to 2. So if you want to calculate TL2, how many are connected to 2? 4 and 5 are connected to 2. Isn't that?
Yes.
See?
Yes.
So then that means we have to calculate two values here. TL2, I will write TL2 is equal to, if I take this 5, TL2 is TL5 minus TE of 2 5. TL5 is 30, TE of 2 5 is 7, 23. Another value is TL of 2 is equal to, I have to take 4 now, TL4 minus TE of 2 4. TL4 is 19 minus TE 2 4 is 9. So it becomes 10. So this value is this is the minimum value. Therefore 10 is the answer for TL2. So here TL is 10. Got it? Now lastly I have to go to 1. So 1 is connected to 2 and 3. So you can calculate TL1 using two criteria. One is TL2 minus TE of 1 2. TL2 is 10 now, minus TE of 1 2 is 10. So you are getting 0. Next TL1 can also be found out using this. So TL3 minus TE of 1 3. TL3 is 11 minus 9, which is 2. So among these two, minimum is this. So minimum is this. So 0 is the TL value or 1. Got it? Now this is how we have to calculate TL. Now once you calculated TL and TE, now the next thing is slack we have to calculate. Slack, that we can do in the form of a table. Once you know the slack, then the critical path can be determined. Now here, let us calculate slack for each event now. Slack is given by TL minus TE, that you know. So slack is equal to TL minus TE, that is the fourth step. To find slack for each event. To find slack, yes. So we know that S is equal to PL minus PB. Critical path is the one which has zero slack or most negative slack. So this is the fourth formula we are using. Now let us arrange all this event PL or PE first, then PL, then S. We can have a table like this. So all these values are in days. So there are totally 5 events here. 1, 2, 3, 4, 5. So all these values are in days. Yes, now let us write. Already we have these values. For the first event, this is 0, PL is also 0. Second event, 10 and 10, both are 10. For the third event, 9 and 11. 9 and 11. For the fourth event, 19, 19. Both are 19. For the fifth event, it is 30, 30. Slack is the difference between these two. So PL minus PE. So it is 0, 0, 2, 0, 0. For 4 events, slack is 0. For 1 event, it is positive. So we have to take 0 or most negative thing. So we have to connect all these events which have slack 0 value. So then 1, 2, what is the critical path now? Critical path is the path which connects the events having 0 slack or negative slack. So your negative slack is not there. So what is the critical path? 1, 2, 4, 5. Correct? 1, 2, 4, 5. So that you can show in the diagram by a dotted line like this. 1, 2, 4. This is the critical path for the given network. Now one part is over. Now he has to find out the probability of completing the project in 35 days. This is the second point. So this you can do using normal distribution. So probability, the normal distribution curve you can use for this. If you have studied in the probability to find that, which you have studied in the module 3. I have already explained in the videos. So to find the probability, we need to calculate one more thing, that is the standard deviation you have to calculate. So after getting standard deviation sigma value, so then only you can find out this probability. So standard deviation is given by formula is there. So this is what we are using in PERT. Sigma is equal to, for any event, standard deviation of for any activity you can say, for any activity, because it depends on the activity. Standard deviation of any activity is given by the formula. If you know this formula, P minus T naught by 6. Tp minus T naught by 6 whole square. This is another important formula you should remember if you ask you to calculate probability. Now let us calculate this sigma value for all the activities. So we have to calculate once again. There are how many activities are there here? 1, 2, 1, 3, 3, 4, 2, 4, 4 plus 3, 7 activities are there. So for the 7 activities, we have to find out the sigma. So what we can, for finding sigma, we need the values of Tp and T naught. So first value is T naught, last value is T. Only those two values we have to take. Let us have this in the form of a table. So event or not event, activity. It is for the activity. Activity T naught Tp sigma. We will have it. Okay. Already we have these values. So there are totally 7 activities, you will be having 7 values of sigma. So let us write down from the given data, let us write down for 1-2 activity, for the activity 1-2, it is T0 is 6, TP is 18. For 1-3 activity, it is 5-17, 5-1-17, all in days. Next for 2-4, for 2-4, 4 and 22 are there. So that means 4, okay, 4, 22. Next for 3-4, it is 4 and 16. 4 and 16. Then for 2-5, it is 4 and 10. 4 and 10. Then for 3-5 or 4-5, for 4-5 it is 4-22. 4-22. Then you have for 3-5, 2-8. So these are the values. Now we can use this formula. Use this formula for standard deviation. Get the values for all the things. So TP minus T0 by 6 whole square. TP is 18, T0 is 6. So 18 minus 6 12 square is 144. Like that you have to calculate.
Divided by 6.
So divided by 6. 12 divided by 6, 2 square is 4. 17 minus 5, 12. 12 by 6 is once again 2. 4. 18 by 6 is 3. 9. 3 square is 9. 12, 2 square is 4. 6 by 1. 22 minus 1, 18. 3, 9. Then 6 by 6, 1. Okay. I think this is sigma value. So we got the sigma values now for all these, not sigma square. Actually this is sigma square. That is variance. Standard deviation square. Okay? Which is also called as variance. So sigma square is obtained using this formula. Now the next step, we know the critical path now. Now we have to calculate the deviation along the critical path. Now we have got the values for all the paths here. Now we have to get the deviation for the critical path. Now how to do that I will tell you. So deviation along the critical path. Deviation along the critical path. We know the critical path now. 1, 2, 4, 5 is the critical path. Now we will write deviation along the critical path. So critical path, we know it is 1, 2, 4, 5. 1, 2, 4, 5 means how many activities are included? 1, 2 is included. 2, 4 is there. Then 4, 5 is there. Correct? 1, 2, 3. There are 3 activities in that. Now what we have to do is the deviation along the critical path sigma is given by square root of sigma y square. So what is the meaning of this? Square root of sigma y square, like this. Capital sigma y square. Here we have calculated, actually this is nothing but your sigma y. Now for the critical path we are taking the standard deviation as sigma. Now what happens? There are 3 paths in the critical path. Now we have to take the sigma y square values for these 3 paths and we have to add. That means it is nothing but square root of. What are the values you have to take now? Sigma y values you have to take. We have to take for 1, 2. 1, 2 is the value is 4. Then plus. For 2, 4. For 2, 4 it is 9. Plus for 4, 5 it is 9. So take the square root of that. What is the value? 9 plus 12, 18, 22. So root of 22. Square root of 22.
4.69.
4.69. That is the standard deviation of the critical path. Got it? Standard deviation of the critical path. Now we have to take the normal distribution curve and we have to calculate. So for that we have to calculate that standard normal being limit. So this I have explained earlier also in module 3. Z we have to take. So Z is equal to here Ts minus Te by sigma. Z is equal to Ts minus Te by sigma. This is the standard variant we have to take. Now the thing is here is, so in how many days this project is getting completed? 30. So that is this value. Te means this is T of last event. So here I will write this Ts is nothing but given. Ts is nothing but it is nothing but for that is the what you can say. Here you are given what is the completion of the probability of completion of the project in 35 days. You know, so this Ts becomes 35 days. Project completion 35. Then T is the last value is 30. That is your T. Scheduled is T. Suppose if at all if it is delayed by 5 days more, what is the probability it can be completed? It should complete by 30. If it is not completed within 30 days, suppose if it is continued, what is the probability that the project can be completed in 35 days? So that means your T is 30 and sigma is this value 4.69. Now calculate this Z. Calculate the value of Z. This is for the first case. Z is equal to 35 minus 30 divided by 4.69. What is this value? What is this value?
1.066.
1.066. So for this, from the standard normal distribution table, you have to get the value of P of Z. So from standard normal distribution table, P of Z we have to get. Suppose if Z is this much, what is the value of P of Z? Actually that will be provided in the examination. Standard normal distribution table will be provided in the examination. Here the value for 1.066 from the table you can write it as 1.066. Exact it is not available, but you can interpolate. So what happens here? He has given the thing for 1 and 1.1 he has given. For 1 and 1.1 he has given the value of P of Z. So we have to interpolate. I know how to interpolate. You people know how to interpolate. So here for Z is equal to, I will use here, for Z is equal to 1, the value of P of Z is 84.13. Of course it is in percentage. 84.13%, or it can be written as 0.8413 in decimals. Okay. For Z is equal to 1.1, because we have to interpolate, P of Z is equal to 86.43. Now can you interpolate? Interpolate what is 0.8613. So we are going to get a value between these two. For Z is equal to how much? 1.066. 1.066. So I think you can interpolate 2/3 ಬರುತ್ತೆ. 2/3 add ಮಾಡ್ಕೋಬೇಕಷ್ಟೇ. So that means what is the difference between these two? ಅಥವಾ ಇದಾದ್ರೂ ಪರವಾಗಿಲ್ಲ. You take the difference between these two. 2 ಅಲ್ವಾ ಇಲ್ಲ? Difference is 2 ತಾನೆ. 2 ನಲ್ಲಿ 2/3 ಎಷ್ಟು? 2 ನಲ್ಲಿ 2/3 ಅಂದ್ರೆ 1.33. So that means almost it is 84.13 plus 2/3 of 2. What is this value? This is the value of P of Z by interpolation. You can do it by calculator. Just 84.13 plus 1.33.
85.46.
That is the percentage. It is in percentage. So we can write it as 0.85. Just like that. This is the probability. Probability value always will be between 0 and 1. And it is positive. So the probability of completing the project in 35 days is 0.8546 or 85.46%. Another thing is asked second. Suppose if what is the probability that it can be completed in 30 days? So then what we have to do is TS also is 30, T is also 30. So TS is equal to 30, T is also 30. So then what happens to Z? Z becomes 0. See, TS is 30, T is also 30 means 30 minus 30, 0. For Z is equal to 0, probability is 0.5 or 50% from the table. That's all the answer. That means the probability of completion of the project in 30 days is 50%. Whereas the probability of completion of the project in 35 days is 0.8546, 85%. That is more actually. More time is given, therefore probability is also more. So this is next step of finding the probability that whether the project can be completed within certain days. So for that, additional steps. So 20 marks question they may ask like this also. You have to evaluate the critical path. Then for the critical path, you have to evaluate the standard deviations. Then for each sigma is the standard deviation for the critical path. For that you need to calculate the sigma y. Sigma y they are the standard deviations for each. This is sigma y square. Sigma y square. So we for each this thing we have to calculate sigma y square. Then along the critical path, how many activities are there? For those the values of sigma y square will be added, and we have to take the square root of that. And using that, we can calculate the standard normal variate z, and after z, get the value of p of z from the standard normal table. So if you don't get the value exactly, you have to interpolate. So here we have to interpolate it. Directly if you get it is okay, otherwise you have to interpolate the value and get the probability in percentage or in decimal. So this is the complete picture of evaluating a project technique. There is PERT. This is nothing but PERT. After finding the critical path, we have to find in how many days that project can be completed. This can be done in the reverse way also. Sometimes they will ask you, what is this probability they may give? How many days it will take? Like that also they can do. So in that case, what happens here? We have to find out the number of days of them. So that is another thing. Okay. So here, the number of days is given. Within those days, what is the probability of getting the project completed? Like that they have asked.